In Math 12, we need to be aware of how to algebraically manipulate complex factors in rational expressions, and we have to be very careful when we deal with trig identities, when we involve trig in there as well. So with binomial factors, we have to make sure we understand that we cannot cancel when there's pluses in there. Fractions are times and divides, so these pluses and minuses do not allow us to cancel these because they're not factors. Pluses and minuses make them non-factors. When we group them, we then have factors. Okay, so we can't cancel things like 3 and 3 here like this. This is not allowed. We also have to be careful with when we start involving trig. This x here is not a factor. Okay, the sine x altogether represents a factor. We can cancel out something that matches that sine x as a factor. So what can't happen is something like this, canceling this x, which is a times, that's okay, that's a factor, but we cannot cancel with that x. Okay, that's not allowed because they are not factors. So we have to be able to understand how to deal with factors. We also need to understand how to combine these expressions. So for example, here we would need a common denominator. So if I were to simplify this, I could have something like this, x plus 2 over sine x plus, I'm going to put this in the numerator, this is going to be x minus 1, x minus 3 over x plus 3. Okay, this nothing simplifies, and then we can get a common denominator. To get a common denominator, I have to multiply this expression by sine x, top and bottom, to balance the fraction. I'd have to multiply this expression by x plus 3, and now we have a common denominator. Now, because we're adding, we're going to have to expand these brackets and then combine like terms. This gets really messy, but we would have to do that in order to be able to evaluate that numerator. But before we do that, we need to understand the factors involved and how to get common denominators. So the other thing is trigonometry. We're going to be moving from the triangle to a circle, which we did in grade 11. We also need to then understand how the circle relates to a function. So we're going to deal with circles, graphs, or functions, and then we're also going to deal with something called identities, or how we can connect them algebraically. So we want to see first, we're going to need to understand how this circle graph is going to, we should understand this circle graph. We should understand this circle as positioning. So the position x and y identifies the angle in the circle, their positional angle in the circle. The sine and cos relate to y and x respectively. So sine goes with y, cos goes with x. And in a unit circle, we can just say that the sine is the y value and cos is the x value. Okay, that only works for a unit circle. But based on this circle, then we're going to be able to get a graph, a sine graph, based on how the y value changes as we rotate around the circle. Okay, and we're going to rotate around the circle in this direction, in the positive direction, and we're going to see what kind of function traces out from that. We're going to end up with something called a sinusoidal graph. So we're going to go from the circle to the graph, but we're also going to go to algebraic relationships. So if we focus on this circle, but look at the triangle, so look at it in terms of triangle trig, that's a right triangle, and we can start generating relationships. So for example, since it's a right triangles follow the Pythagorean relationship. And we can end up with a relationship that looks like this. Well, since in a unit circle, the cosine represents an x value, we can take that x value and square it, and then we can add it to the sine. Well, since again it's a unit circle, the sine value represents a vertical height, and we can square that, so we get a squared plus b squared must equal the hypotenuse, which is 1. And we end up with relationships like this, and these are called trig identities. These are just algebraic relationships involving trig functions.